Hello everyone, I welcome you all back in this course Introduction to Sequence Stratigraphy, and in this class we will be continuing our discussion on base level and accommodation, and this is from our previous class where we introduced this concept of base level and accommodation. So already we know that the proper relationship in terms of the controls of stratigraphic architecture is commonly portrayed by the interplay between the rate of change in accommodation as a function of base level change and the rate of sedimentation. The amount of available accommodation at any given time and any given location commonly equals to the balance between how much accommodation is created or how much accommodation is destroyed by the factors like tectonism, like factors like sea level changes, and how much of this space which is created or destroyed by these factors is finally consumed by sedimentation at the same time. So, this is a very dynamic system where simultaneously the space is created by several factors, and some processes, particularly the surface processes, leads to generation of sediments which are derived, transported and deposited to consume that space. So, at the end of the day what we get is finally some amount of sediment accumulation which gets preserved in the stratigraphic record. And as an earth scientist, when we look at the rock record, we get that preserved portion only, and from that preserved portion we try to reconstruct all these processes in terms of what are the positions of the base level and how much was the accommodation available at that particular time. So, commonly we represent this complex relationship between creation of accommodation and its consumption using this very basic fundamental equation T plus E equals to S plus W, where T is the rate of tectonic subsidence, E is the rate of eustatic sea level change, S the rate of sedimentation, and W the rate of change in the water depth. So, basically in this equation the left hand side, which is basically the tectonic subsidence, and E is eustatic sea level change. So, these two factors are responsible for the creation or destruction of accommodation space in terms of changing the ocean volume, changing the overall space in that particular ocean body. So, when we are saying T as positive, that means there is a subsidence going on. If some uplift is going on or some exhumation is going on, T is considered as negative. Similarly, if we are getting a sea level rise, E will be positive. If there is a sea level fall, E will be negative. So, the resultant accommodation that is created by these factors in the left hand side is controlled by what are the conditions of this T and E. So, somewhere T may be negative, E may be positive, somewhere T may be positive, E may be negative, somewhere both may be positive, somewhere both may be negative. So, already in the previous class we have discussed about this combined effect of tectonic subsidence and relative sea level change and how it controls the base level and accommodation. So, this left hand side of this equation represent those conditions. The right hand side is basically the consumption of that particular space. So, we can get a complete consumption when this is very high or water depth is very high. So, when S will be high, it will be consuming that space. So, definitely the W will be the remaining portion of that particular space. So, if you have this much of space available, that is T plus E. So, definitely this T plus E, the space created, will be consumed by sedimentation first, and the rest of the portion is the W, which will occupy the rest of the portion. So, S is the main factor in this right hand side, which is the rate of sedimentation, the amount of sediment finally accumulating, and rest of the portion is the final water depth available after the accumulation of the sediments. So, this equation is a very simple but very effective equation used in sequence stratigraphy, particularly in understanding this relation between accommodation and base level change, accommodation with respect to the sedimentation. So, in this equation, positive values on the left hand side, it reflects that there is an increase in the accommodation. So, that can be caused by some tectonic subsidence, or that can be caused by some eustatic sea level rise, or maybe both together, eustatic sea level rise with a tectonic subsidence. So, effectively that T plus E component is positive. Even it can be positive if one of the component is negative, but the other component is quite large and nullifying that negative effect. So, T may be positive, E is negative, maybe there is a sea level fall, but that amount of T, that is the tectonic subsidence, is so high that effectively there is creation of accommodation space. Similarly, if you are getting a negative value for T plus E, that indicate a loss in the accommodation, which may be due to some tectonic uplift, which may be due to some eustatic sea level fall, or maybe combination of both. So, in such cases, this T plus E will altogether will have a negative value and overall accommodation will be less with respect to the previous condition. Now, if we look into the right hand side of that equation, positive values on the right hand side indicate an increasing sediment thickness or deepening water depths. So, if the amount of sediment thickness is less, W value will be more. If the amount of sediment thickness is high, W value will be less. While the negative values signify erosion or shallowing of the water depth. So, in this equation, if this value is getting negative, what is the meaning of that? That means S is maybe not accumulating, sediments are not accumulating at all. So, the entire portion is getting covered up by W, or maybe even the water depth is also decreasing. So, this is becoming negative. So, the right hand side altogether can become negative in that case. So, a negative value in the right hand side commonly signifies erosion or shallowing of the water depth. The distinction between these two members of the accommodation equation, that means the creation or destruction of accommodation space, left hand side, and the consumption of the accommodation space, right hand side. This is one of the key theme of sequence stratigraphy, which allows one to understand that the fundamental mechanisms behind the formation of different stratigraphic successions, cyclic nature of the successions, and commonly we define them in terms of system strats and the different types of sequence stratigraphic surfaces. So, this particular equation, this T plus E equals to S plus W, is one of the fundamental equation we commonly use to understand the relation between base level change and accommodation, relative sea level change and accommodation, and what is the resultant sedimentation pattern that gets preserved in the sedimentary succession in the stratigraphic record to produce different sequence stratigraphic elements. So, accommodation may be made available in both fluvial and marine environments by the combined effects of climate, tectonism and sea level change. So, particularly when we look into the downstream part of the fluvial system, the fluvial graded profile will also be affected by these factors, where climatic change will lead to change in the relative sea level position. Tectonism will directly affect the basinal volume, and in that way it will create or destroy the accommodation, and definitely the relative sea level change, rise or fall in the sea level change, both eustatic and relative. So, all these factors together commonly control the accommodation available in the marine basin, and not only in the marine basin, but also in the fluvial part, particularly the downstream control part of the fluvial system, by controlling the position of the fluvial graded profile in that particular area. So, these allogenic controls modify the balance between sediment supply and the energy flux in the depositional environment, which leads to the manifestation of different processes like erosions or sediment accumulations. So, when erosion is going on, it is basically a negative accommodation, or when sediment accumulation is going on, it is commonly a positive accommodation condition. So, this already we have discussed in the previous class, where we have understood that how this energy condition, energy flux and sediment supply, they are interrelated with each other, and that control whether there will be negative accommodation, positive accommodation or zero accommodation. So, in the marine systems, we can describe this entire process, entire mechanism using this particular flow chart, where the accommodation creation is controlled by several factors. So, it starts from sea level change, eustatic change, or it can be tectonic change which may cause change in the ocean volume, and these two factors together can relate to or lead to change in the relative sea level condition, either rise or fall in the relative sea level condition. Now, depending on that relative sea level condition, we can have different energy flux, because as the relative sea level is changing, the energy conditions at different parts of the basin, these are also changing. So, depending on that energy flux and based on the relative sea level change, what we get is the position of the base level in that particular basin for that particular relative sea level position. So, this base level position or this base level change gives rise to creation or destruction of the accommodation. When this base level or relative sea level is changing, we can get shift of the shoreline either towards the land or towards the sea. So, we are getting transgression or regression, but that transgression or regression is actually controlled by creation of this accommodation and how much this accommodation is consumed. So, this consumption of the accommodation is controlled by this factor, the sedimentation. So, this consumes the amount of accommodation available over there. So, when we come to this accommodation part, it is a two-way traffic where one part is consuming that accommodation, one factor is creating that accommodation. So, depending on whether it is a positive accommodation or it is a negative accommodation and what is the final water depth available over there, this S plus W factor in the right hand side, that will control what will be the nature of the shoreline position, whether it will be shifting towards the land or it will be shifting towards the sea. So, we get transgression and regression in that particular basin. So, when we are discussing about eustatic sea level change, when we are discussing about relative sea level change, all these are actually linked together and they act in coherent way to control what will be the base level position in a particular marine basin, and that base level position when associated with the energy flux, when associated with the amount of sediment coming into the system and how much it is getting reworked, will control what is the final accommodation and how much is the value of this S plus W on the right hand side. So, that S plus W factor will control whether there will be transgression or regression. So, when we have a transgression or regression going on, so definitely the conditions available in that basin is changing. So, the energy flux which commonly lowers the base level through different processes in terms of the energy like wave energy, currents like tidal currents, like contour currents, different types of gravity flows, which are very common in marine environments. So, they commonly supply the energy flux, they commonly are responsible for the energy flux and they create reworking of the incoming sediments, and this energy flux decides that whether the sediments will be allowed to be deposited or they will not be allowed to be deposited. So, the base level position is controlled by this energy flux. So, the short term climatic changes, for example, some seasonal to sub-seasonal time scale changes in the climate are commonly accounted for under energy flux. For example, some storms, maybe some monsoonal changes in the current systems. So, this can have some changes in the wave propagation directions, wave energy conditions. So, they can have an effect on the base level position. Whereas, when we talk about the long term climatic changes, for example, we have discussed about the Milankovitch type cycles, where the climatic changes occur in terms of thousands to lakhs of years. These commonly result in controlling the eustatic sea level fluctuations, and that can control the relative sea level position. So, when we talk about this energy flux, this stands for the dynamic balance between environmental energy and the sediment supplied into the system. So, as there is an increase in the energy flux relative to sediment supply, that will lead to the base level fall. And when we are talking about base level fall, as we have discussed in the previous class, there will be a loss of accommodation, there will be negative accommodation. Exactly the reverse of this is expected when the amount of flux, energy flux is less with respect to the amount of sediment supply. So, a decrease in the energy relative to sediment supply will lead to base level rise, and when we are talking about a base level rise, it is actually the gain of accommodation. We are getting a positive accommodation over there. So, I will just request you to go back to our previous class, last class, where we have discussed about this in more detail using one example from marginal marine environment. So, the relative sea level changes are independent of both sediment supply and the sedimentation. Sediment supply depends on the tectonics in the continental area, the climatic condition which leads to how much of sediment is supplied into the system, and then the sedimentation, that means the amount of sediment finally accumulated. It will depend on the position of the base level, which is again related to the energy flux under that particular base level condition. Now, if I talk about the fluvial system, it is almost similar, particularly when we talk about the downstream controlled fluvial systems. So, in case of downstream controlled fluvial system, again we can find out several factors, particularly the allogenic factors which are responsible. So, in case of downstream control system, the main control factor is the base level, that is the marine base level, and along with this marine base level, the second factor that will control is the energy flux which is available with respect to that particular base level position. These two factors together will decide what will be the position of the fluvial graded profile. So, this fluvial graded profile, say for example, if I draw a marginal marine basin and then you have this downstream controlled part of the fluvial system. So, this base level, its position, if it is falling, it will come down to this. So, this fluvial graded profile has to adjust itself like this. If the base level is rising over here, the new base level is this, and the fluvial graded profile has to change its position like this. So, this is the factor base level change and the energy flux which is available with respect to this base level change, as well as the energy flux of the fluvial system itself. If the energy flux is very high, it will be eroding more. If the energy flux is less, it will be eroding less. So, these two factors together will control what will be the resultant fluvial graded profile in the downstream part, and this fluvial graded profile, depending on how much erosion or deposition is allowing, how much is the energy flux with respect to this fluvial graded profile, this will control what will be the resultant accommodation. So, this is either creation or destruction of accommodation depending on what is the position of this fluvial graded profile in that part of the marginal marine environment. Now, this accommodation will be consumed by the third factor, that is the sediment flux or the sediment supply, which will try to consume this accommodation. I am talking about this in terms of downstream control system, where this entire process of creation or destruction of accommodation is directly related to the change in the base level position in the marine basin, because here there should be an equilibrium between the base level and the fluvial graded profile. So, in the downstream control part, this base level and energy flux controls the position of the fluvial graded profile, and that controls creation or destruction of the accommodation in that part of the fluvial system. And when that accommodation is created or destructed, then comes the sediment flux, sediment supply, and it will try to accumulate over there depending on the energy condition available over there. So, it will try to consume that accommodation, and what we get is finally the resultant stratigraphic succession formed in that part of the fluvial system. And depending on this amount of accumulation, what we can expect is either the fluvial system is covered up by marine system, so we get a transgression over here, or the fluvial system will gradually come over the marine system, so we get a progradation and we get a regression over there. So, which one will be allowed will depend on how much sediment is supplied and how much of this accommodation is getting fulfilled. So, again I will go back to that basic equation T plus E equals to S plus W. So, when the S part will be very high, then the T plus E will be completely occupied by S, and we can get a scenario like this where the progradation will occur. Now, if the T plus E is not that much occupied by S, then it will be occupied by W, and we will get this kind of condition where the fluvial system will be covered up by the marine system. The scenario remains same for upstream control setting, where just this base level part is not directly involved, because in the upstream control fluvial system we know that the fluvial graded profile is not controlled by the base level change. So, what is the control factor over here? It is the tectonics of that particular terrain, that particular river system, which actually gets associated with the energy flux of that river system, and together they will control the fluvial graded profile. So, this fluvial graded profile, which is controlled by the tectonics, slope, energy flux of the river system, will be responsible for the creation or destruction of accommodation, and through this energy flux and tectonics, which will be resulting in the creation of sediments which will be supplied into the system. So, they will try to consume this accommodation. So, definitely in that part we will get a completely different types of stratigraphic architecture for these upstream controlled fluvial systems, and in this kind of system the resultant architecture will be significantly different from this downstream controlled fluvial system. So, these differences we will discuss in more detail in terms of different systems tract in our later classes, where we will discuss about the fluvial sequence stratigraphy. So, base level changes are commonly measured independent of the sediment which accumulates on the sea floor. That means, the base level relative to the datum plane, whereas the water depth, it changes and it includes the sedimentation component, that is the sea level relative to the sea floor. So, there are certain confusion, often people get very much confused about these different terms. Also in this class also we are using these different terms, for example relative sea level, for example the datum plane, for example base level. So, all these have separate meaning. So, when we are talking about the base level, it is independent of the sediment accumulated on the sea floor. So, basically we are measuring that with respect to the datum plane. So, water deepening or shallowing, that may occur during a stage of base level rise as a function of the balance between the rates of creation and consumption of accommodation, which will lead to transgression or regression. So, the trend associated with lateral shift of the facies may occur during base level rise, or if there is a base level fall, it may be associated with water shallowing or water deepening at the point of observations. So, the characteristic stratigraphic architecture will depend on what is the final trend in terms of base level change or water level change, or maybe a combination of both. So, when we get this kind of changeover, this kind of gradation, that indicates a consistent change through time in the sediment supply across the area of observation, which commonly indicates a progradation or retrogradation of the sediment entry points associated with the shoreline regression or transgression. When it is a progradation, it is a regression. When it is a retrogradation, it is a transgression. Whether the sediment entry point is going back or it is proceeding forward into the sea. So, that will be controlled by these factors, the relative positions of the base level and whether the water level is shallowing or deepening. So, again I will refer back to that basic equation T plus C equals to S plus W. So, basically it is the W factor. So, base level is controlling the accommodation and then how much it is consumed and what is the W factor. So, depending on that, whether the point of entry of the sediments into the depositional system is shifting towards the sea or it is shifting towards the land. So, with this I will conclude this particular class. So, in this class, continuing from the previous one, we have tried to understand about the different aspects of base level, the concept of base level and accommodation. We have tried to understand how base level controls accommodation, how base level is controlled by relative sea level, its energy flux, and how these two factors control how much sediment will be finally accumulated. So, the controls vary from marine system to fluvial system. In the fluvial system, the downstream control portions are directly affected by marine base level changes. Its accommodation is controlled by change in the marine base level condition, whereas the upstream controlled fluvial systems, they are controlled by local tectonics and other energy flux and how much is the consumption of the accommodation created by the sediment supplied into the system. So, these are some references for further study. Thank you everyone.